All right, this is question number 2 in that same measurement errors exercise. Now, this question, if you've just watched the previous video, which is question 1, this is exactly the same. We are going to do exactly the same, but the only difference is we have a slightly different measuring tool. Instead of a ruler, we've got these dials, and they are much more precise. Well, they seem to be. So we have to be conscious of that. So what is the mass indicated by A or B? So we're just reading it off there. Now, if you're like me and your eyesight is terrible, you're looking at that and going, okay, well, it starts at naught, it goes around this way, so we are less than 2 kilos. So there's 1.5. So each one of these appears to be 0.1 of a kilogram. So this would be 1.6, 1.7, 1.8. So we're pretty close to 1.8. So if I zoom in as much as I can, if that is 1.8 that is there, and then we're 1 mark past that. Now, if you look at these, there are 5 marks in between each one. So you've got 1, 2, 3, 4, and then that is 1.6. So if we've gone from 1.5 to 1.6 and it's used 5 marks, sorry, erasing everything I've got, each one of those must be 0.02. Now that looks a bit confusing at the moment, but if we're at that, so if I take these and just put them over here, I've got 1.5 there, and then we've got 1, 2, 3, 4, and then that one, which is 1.6. That means that has to be 1.52. Then I should have done these a bit further apart, sorry. Let's go 1.5, 1, 2, 3, 4, and then that one 1.6. So that is 1.52, 1.54, 1.56, 1.58, and then the 1.60. And if I add the zeros at the end, it'll probably make life easier. So each one of these lines, each one of these tiny little lines, is going up by 0.02. And that'll become important when we get to question B. So if we read this, that is 1.8. I'll put the 0 at the end just so we can see it. And then we're going up 1 more. So that means this line here is 1.82 kilograms. So very similarly on this one, we're at 4, 4.1, 4.2, that'd be 4.3. So 4.2 is there. And we are at 1, 2, 3 of them. So we are at, if we look at that one, that will be 4.26 kilograms. So that's our 2 measurements. So let's just zoom back out a bit. So A is 1.82 kilograms and B is 4.26 kilograms. Now, what we're looking for is the precision or the limit of reading, and that's what we actually just worked out there, that each one of these is 0.02 of a kilogram. So that is our precision or limit of reading. We can only get to that accurate. So 0.02 kilograms. So we had to work out what increment each one of those little lines was. All right, so the largest possible area is plus or minus half of that. So if I go plus or minus and 0.02 over 2, that will give us half of it, which would equal plus or minus 0.01 kilogram. So that is our largest possible error. We will be plus or minus 0.01 kilogram. Upper and lower bound for each measurement. So A, we're going to have between 1.81 and 1.83 kilograms, because I'm just adding it to and taking it away. And B will be between 4.25 and 4.27 kilograms. So that is our upper and lower bounds. Now, these are exactly the same as question 1. They're just a little bit more complicated because they're smaller numbers, got a few decimal places and all that sort of thing. But it's the same process. So the relative error for A is going to be the absolute, the absolute error, which is 0.02 divided by the measurement we took, which is 1.82. And the absolute error for B is going to be 0.02, because that's still the absolute error, and divided by the 4.26, which was the measurement we took. I'm writing them both down because I've got to get the calculator up and I didn't want to have to do it twice. So 0.02 over 1.82 will give us, and we're doing this to 3 decimal places, so when you chuck that in, you'll find that that is, what have we got, 0.011. So it equals 0.011. And for part B, where we've got 4.26, will be 0.05. 0.05. So that's our two relative errors. So that's question E. Question F, we're looking for the percentage. So all we do is we take our relative error and multiply it by 100, and that'll give us our percentage. We end up with A being, and I'm moving decimal place twice, so I'll have 1.1%. And for this one, 1, 2, I'm going to, I should have done 3 decimal places, sorry. B, I'm going to end up with 0. Where am I going? Stop that. 1, 2. I've done not enough decimal places, have I? Yeah, no, I've done it again. Sorry. That should be 0.05, it was 3 decimal places, which ends up being 0.5%, because that is 0.005 times 100. And that's it. So it's exactly the same as question 1, just the dial was a bit more finicky, a bit closer, it was a bit harder to read. And from that, you can actually see why we get these absolute errors and why we have a precision or a limit of reading. Hope that helped.